Part 16, AC Motors. Three-phase induction motors already discussed part 14 and part 16. Now single phase motor discuss now here. Number 1, universal motors AC/DC combined. Number 2, synchronous motor, permanent magnet motors, shaded pole motors, hysteresis motors and reluctance motors. Another, induction motors, squirrel case. A, capacitor start split phase motors. B, shaded pole motors. C, permanent split capacitor motors. And slipping, number 2, slipping, repulsion and repulsion start. Now, single phase induction motors, these motors are normally lower HP ratings and also fractional HP horsepower ratings. The most common single phase motors are the split phase, number 2 capacitor start, number 3 permanent split capacitor, and number 4 shaded pole types of motors. Number 1, split phase motors, single phase, are constant speed motors. The motor consists 2 windings, main windings and auxiliary windings, with centrifugal switch. Here is the main winding, 230 volt AC, single phase 50 Hz, main winding, and auxiliary winding. This is a rotating part, and here the centrifugal is normally closed, and motor at the certain speed, centrifugal switch open. These switches are open, but normally this centrifugal switch is closed. Open. The motor oscillates with only the main winding being energized. The auxiliary winding cut out, and split phase motors provide a low or moderate starting torque, mainly used in small applications. Capacitor start motors. The basic difference is that capacitor connected in series with auxiliary winding. This is a auxiliary winding. This is a main 230 volt here connected to terminals, and centrifugal switch and capacitor in series. The capacitor motor, basic difference already discussed. The capacitor connected the series with this auxiliary winding. This is auxiliary winding. The locked rotor torque and accelerating torque by the capacitor. This is the capacitor. This is the rotor. This is the centrifugal switch. Here, run the motors and cut off centrifugal switch and off auxiliary winding. The normally closed condition, motor up condition is the centrifugal switch closed. After acceleration of torque, the capacitors, run the motors and cut the centrifugal switch. This is the off centrifugal switch and off capacitor and auxiliary winding. Main winding energized. The motor load run. The useful application is pump, air compressor, etc. Pump and air compressor, etc. Number 3, permanent capacitor. Here main winding and auxiliary winding and capacitor are continuously energized. Here energized. energized. The main winding and auxiliary winding and capacitor totally energized in main in parallel and in series capacitors and auxiliary windings. The result, the higher power factor in comparison to the others motors, but the locked rotor torque is low. The normal application is for directly driven fan or blower and not for belt driven loaded. Mainly fan motors are used here. Number 4, the shaded pole motors. There is no auxiliary windings, only main windings. Auxiliary winding is in its place the solid copper loop sitting around the small portion of each salient pole. This is the winding, main winding, the rotor and copper, solid copper. This is a solid copper in setting in core. This setting coil is capable to producing a limited torque during the accelerating and running. The low efficiency, power factor and starting torque. The motor mainly in low torque application, a small fan, etc. These are our induction motors. Mainly single phase induction motors are discussed here. Induction single phase. Here AC/DC combined universal motors are armature provided here, and it is used as mixing machines, drilling machines, etc. The universals AC and DC motors are here used as a principle of DC. We already discussed on DC motors part 12.